Hi, hello everyone. Last time I mentioned that this time we're going to work on the player and we're going to start with the gameplay. So we're going to start with the player input and then just moving the player around. So we're going to create it. So let's just get started with that. So for that, first of all, we're going to refactor a bit our main so that it becomes engine and so in main we had render, it's going to become engine now. We're just going to refactor it so that it has a structure of a game engine. So let's just call this engine where we had render before. Let's export it. Then let's get rid of all this drawing code here. That's quite all right. Then what we're going to need is 1 second. All right, sprite render. We're going to leave sprite renderer here. That's quite all right. All right, and then we're going to copy this. And let's rename our main to engine and create a new main. And then let's just copy this. We're going to get our engine and then we're going to call draw. This function is going to be a bit more involved now. Then, not that. Actually this, so let's just close it. Let's format it. All right, let's save this everywhere. And it just works, but we don't draw anything. So how are we going to do drawing since I removed? So just leave sprite render and sprite render frame end and frame pass, everything in between just delete it because we're not going to use it anymore. We're actually going to do this. We're going to have public on update. And you can pass here delta time. We're going to discuss it a bit later. And then we have onDraw. And let's just call onDraw here somewhere. Let's call it here. And on update, let's call it here. And for delta time, we're just going to pass 0 for now. We're going to deal with that later. And then in our main, let's just do this. We're going to call our render, but this will be called engine now. Let's call it engine. And let's say just engine on update does nothing yet. We're going to do that a bit later, but on draw, let's also create that function. And also we're going to deal with it later. We're just going to create it for now. All right. Then we're going to have our game objects now. So let's just call new folder game, and then let's create player in it. So player ts, and we're going to export class player. So what is our player going to need? Well, we're going to need to draw it, so we're going probably to need to have draw rect. So let's say private draw rect. Rect. Then private texture as well, and we're going to need source rect. For our player, let's just resolve this. Import and now in constructor. If you remember, we had player sprite, and I can import it here. So it's not get texture, it's rather sprites. Sprites, and then it wasn't player, it was something like what was it? Let's see in our sheet. Player ship red, there was a blue one. Here. All right, so let's get that. And then we can just assign texture, draw rect, but we actually have to copy it. And same for this draw rect. But I haven't implemented copy. So the point is this source rect is passed by reference. So if we modify it here, we're also going to modify it in content sprites. So I don't want to do that. I actually just want to copy it. Might be better to call get sprites, but anyway, you can refactor that on your own if you wanna. Maybe have some method, but let's just create public copy rect and then just create a new rect from these values. That should be fine. Let's save everything and then let's create a draw. So we're going to pass sprite renderer here of sprite renderer, draw source, sprite source, and actual draw rect is second argument. So this is wrong suggestion. And source rect is third argument. So if in our main we create a player, const player, new player, that's all right for now. If we draw the player, sprite renderer, it's probably private. Yes, it is. Let's just make it public. And let's just save everything. If something is wrong here, let's see. Cannot read it. So we probably didn't find it by key. I think I know what it is. Here. Let's just get rid of in our content, find where we called for name, and let's just get rid of that PNG extension. So we're going to get these keys without this extension, and now it works. So we have our player. So what do we want to do now? Well, we want to move that player. So I'm going to create a input manager, which is going to be responsible for our keyboard input. So let's do just that. So let's create a new file. That should be, come on. All right, let's see what am I going to have here. Private key down. It's going to be actually map, but I'm not going to use this suggestion. Key string, boolean, that's fine. Then we're going to have constructor. Then you can add this window, add the event listener, and then I'm just going to remove this. Actually key down, and we can use E key. And these keys, if I just go to open the new page, I'm just going to copy paste from there. Open it on another screen. But you can find documentation here for keys and what are the values of the key. So keys, as you can see, you cannot see. We're actually going to use this. So we're going to use key, and if we say arrow down, arrow up, arrow left, arrow right, it will read our arrow keys. So we're going to use that. So then here we're just going to say same as here, but we're going to say false because it's key up. Now, all right, and then I do want to have two methods here. What will I call them? A second here. Okay, that's perfect. So we're going to have public is key down, and then we're going to have public is key up. So this is just negation of this. All right, perfect. We have our input manager. So in our player, we can define some const. Let's say speed is 5, or just maybe player speed, so that we don't have any collisions in the names. And then we're going to have update. So now the part that I mentioned. So we're going to say it like this. right, let's do it like this. So I'm going to have private movement. You're going to see why in a second. Is of vec2 create. So it's going to be of type vec2, and then we're just going to say on each frame whenever we update our player. So we're just going to set it to 0. And then if this, we don't have input manager, so we need to add it here. And then let's just resolve this quickly. Input manager is key down, arrow up. All right, we're going to say here as well private. And then else if, right? We're checking if arrow is up, then we go in Y direction, and then if arrow is down, we go in Y direction in different direction. And then we can do the same for arrow left, right, and arrow right. So if we press left, we're going to move to the left in X direction. If we press right, we're going to move to the right. And then, so let's just say here, X direction, and maybe here, Y direction. And let's do just this, is draw rect X plus equals. All right. It won't work because I still need to create input manager here. Public input manager. And let's just get rid of what we do not need. Delete unused imports. Then somewhere here we can just create our input manager. My canvas doesn't make any sense. Oh my god, kind of suggestions are these? Does it have initialize? No, it does not have initialize, so that's not necessary. I'll just get rid of this rotation because that's not used anymore. And then in main, we can now say here engine, input manager. And if I try to move our player, let's just move this up. It's not moving for some reason. Do I have some bug? No. Okay, it's quite clear why, because I need to call player.update. And now the player is moving. All right, left works. It's a bit sluggish for some reason. All right, we'll fix that. It's probably because the screen is a bit here, so. All right, it works. But however, there is two problems here, and actually we're going to tackle the first one. So if you see the player here, it's moving at this speed, it's moving up at this speed, but if you play, for example, move diagonally, so you press right and up, it's moving a bit faster, twice as fast. So what's the issue here? Well, the issue is, so for example, when we're moving here, we might move it with direction 1, 0. If we move up, we're moving by direction 0, 0, 1. But if we're moving diagonally, so we're moving with 1, 1. And the length of this vector is always going to be longer than either this vector or this vector. So let's just recap. So this length is not the same as this length. So here it's the vector is a bit longer, right? Because it's 1, 1. If you normalize it, sorry, if you try to get length of this vector, it's probably going to be something like 141, I believe, because the length is square root of 1 sorry, it's like this, x squared plus y squared, and then you get the length. That's not that important now. And the important thing is it's actually really easy to fix. You just normalize the vector, and then you're going to get you're going to be sure that length is 1. So let's do just that. And in our player, we can just normalize it here. Normalize, movement direction. And then if you try to move diagonally, it's going to retain the same speed as if you're moving down, up or left, right? All right, that. And the second issue has with our, well, delta time, which we're not using. So we're just going to pass here delta time. And why is that an issue? Well, it's actually has everything to do with your computer speed. So if you're not multiplying by delta time, something like this might happen. So let's say that on the first frame you're somewhere over here. On the second frame you're somewhere over here. Then your computer slows down for whatever reason. And on the third frame, instead of being here, you might be here. Or if it's going faster, instead of being here, you might end up here on the third frame. And that's because of the speed of your computer, right? We're moving to the right. But basically, we wanna somehow recap that and actually make sure that on the third frame we end up here. Well, actually, not the third frame. Maybe I should rephrase it. Well, but basically it has everything to do with movement, right? So let's say you want to move from here to here. If your computer is fast enough, right, it might do it in way more frames, right? But if it's slow, it might skip frames, right? But with delta time, we will always make sure that after, let's say that it takes 2 seconds to get here, with delta time, we will make sure that it actually gets here in 2 seconds, right? Regardless of the number of frames. It's just going to be choppier because frame rate is lower, but we're going to end up at the same place. So that's what delta time does. Sorry for explanation, not the best explanation, but delta time is pretty common. So you can find explanations everywhere on the net. If you want to know more as well, so in our engine, let's actually pass the delta time and we're going to calculate it in draw method. So we're going to have now, which is just performance that now. And then we need delta time, and then we need to set up last time to now. I can get rid of this. I don't care if it's in seconds or milliseconds. And let's just create private last time as 0. And then here we're just going to pass delta time. So now everything works, but we're not still using it. So in order to make sure that well, we just need to take into account the delta time. So it's probably going to be either faster or slower. It's probably faster, so we can just speed to 0.25 maybe. That's pretty decent speed. All right, perfect. So now this will make sure that you don't have like some undesired behavior. That's usually if you see games with physics acting a bit wonky, if frame rate is lower or higher, it's because that delta time as well, I think. All right, so further, last thing that I want to do in this video is actually just clamp player to this bounce, so that it always remains in this gray space. So for that, we're going to need to pass width. Now let's just call this game width number, and then you're also going to have private game height as a number. And let's just create a small function, public clamp to bounce. So if drawRect.x is less than 0, we're going to clamp it to 0. So let's go just discuss this quickly. So we have our draw rect, right? And now it's at 0, 0 because we're always looking at this top corner. So if our draw rect by any count goes below 0, we're actually going to reset it always to be at position 0 in X. So it's always going to end up here. So that's the point of this. It's going to be same for y, but let's handle other case. So let's just check if it works, because this suggestion is good actually, I believe. No, it's not. I'm not calling actually clamp to bounce, so we can just call clamp to bounce here. So if I press left, I cannot move to the left, and then right. Right is all wrong, interestingly enough. So I'm going to actually fix it here. I'm never past game width and game height, so let's do just that. So let's go to our engine. We're going to create public bounds, which is of type vector2. And then for bounds, we can just get them from the canvas here. And then here we can pass these bounds. A second, I'm doing something wrong. So if I look at bounds, let's just call it game bounds instead. It's a bit more clear what's happening, so we can pass it here. It's engine. Game bounds. Oh my god. Game bounds 0, game bounds 1. If I save it now, I cannot go left with my player, and I cannot go right with my player. So here, if player dot x plus direct dot x is greater than height, then we set it to width. Then we set it to width minus direct height, and what that means is we have our player, right? But x is here, so we need to take width into account. And if that is greater than game width, so if it's greater than this bound, right? So let's say our player is here, so x plus width is actually greater than width of a game. So we just need to take that into account and then set x to game width, right? Game width minus width of a sprite. So it will place it here. So you can just do the math, but anyway, it's easy to figure out. So let's do just same for y. Less than 0, then it's direct y 0, and then for the height it should be the same code. As you can see here, it's same. So let's just test it. I'm going up, I cannot go up anymore. I'm going down, I cannot down below this. All right, perfect. So that's it for this video. So for the next time, we're actually going to do backgrounds and then enemies as well. So because we need enemies, and then we're going to have one more video, which is going to be probably collisions and bullets, and then we're done with gameplay programming for a while, and then we're actually going to learn how to load fonts. But for now, we're just going to be focused on gameplay for the next two videos. This one and the next two videos are just going to be about some gameplay improvements and stuff. So hopefully you enjoyed this video. If you enjoyed it, please like, subscribe, and you can also follow me on Discord channel where we discuss some ideas. We might bounce some ideas about this series, and there is also WebGL series, which is very similar. It's almost exactly the same. It's just done with WebGL instead of WebGPU. So that's it for this video. So hopefully you enjoyed it, and until next time.